Dr. Zoon, you'll build model bridges out of balsa wood. You'll research design specifications and use the construction caddy, timber cutter, and easy cutter to construct your bridge. Finally, you'll test your bridge using the Pittsco DI-2000.
Hello kids! Today, Dr. Zoon is going to be doing model bridges with you. We're going to build a model bridge that will span a 10-inch gap, and we're going to need the following tools and materials: a construction caddy, a timber cutter, an easy cutter, a pair of plastic vices, wax paper, T-pins, graph paper, glue, a X-Acto knife, a ruler, and of course, wood, balsa wood that is. We'll also be using the Pittsco Bridge Book as a guide for the activity, and we'll use the Pittsco Student Guide to Model Bridge Building. Just looking for a few good ideas, we have lots of books and videos that are available for you to get ideas for your bridge as well. People who design bridges are called civil engineers. They go to college for many years studying math and science to learn how to design bridges that will be functional. As I said, we're going to design a bridge that will span a 10-inch gap. Bridges are built on abutments. These two blocks are serving as an abutment across this 10-inch gap or span. Some bridges are simple beams across the span, and they use just one beam to support a load. A beam bridge can now hold a lot of weight depending upon the size of the beam. One method of increasing the load capacity of a bridge is by adding more beams across the gap, like this. Here we still have a simple bridge, but with the addition of each beam, we increase the amount of load that the bridge will take. Load is the amount of force that is being pressed down on the bridge. Load can be two varieties. One is a dead load, which is the actual weight of the bridge. The other is a live load, which would be like people or cars that go across the bridge. Another way to add strength to a bridge is to use a truss device like this one. In this bridge truss, each of these points along the bottom beam help distribute the load across the beam. The other thing which provides strength for the truss work are the triangles which are included in any truss-like device. Triangles provide stability and aid in the compression and tension of each member. This entire area of the bridge which is above the abutments is called the superstructure. Another method of providing strength to the bridge is to add a substructure to the bridge. The substructure is this area which is below the abutments. Of course, the entire bridge is designed to hold up the roadbed and the live and dead loads that are on it. Before beginning the design of your bridge, you need to be sure that you know what the specifications are for your particular competition. Some competitions will allow substructures, like this bridge has, and others won't. Some competitions will give you specific amounts of length between the substructure and the abutments, and others won't. So you need to be sure that you are aware of all specifications. These may also include what type of wood, what size of wood, and it may include the width of the bridge as well. Another consideration is the type of structure tester that you will be using and how it attaches to your bridge. Once we have our bridge design in mind, it will be time to sketch it out on a piece of graph paper like this. Each square is 1/8 by 1/8 inch, and we're going to draw first the abutments, which we'll space for this bridge at 10 inches across. The next step will be to draw the outline of the bridge, remembering that each structure or each member of the bridge is 1/8 inch wide, so we'll make our lines 1/8 inch wide when we draw the outline. Next, we'll sketch in the diagonal bracing, again remembering that our members are 1/8 inch wide. Once you've completed the sketch of the side view of your bridge, you'll need to also sketch the top view, which will indicate how your roadbed will be designed and constructed. Once your sketch is complete, you'll need to make an accurate drawing of your bridge using either standard drafting materials and tools or a computer drafting program and make a bridge like this one. Don't forget to also make a drawing of the top view of the bridge indicating how the roadbed will be constructed on the bridge. You need to organize your workspace. A good way to do that is to use the Pittsco construction caddy, which has places for your 1/8 by 1/8 by 24 balsa wood, your T-pins, which fit nicely into this oval container, your HD bond glue or colored wood glue. Today we're going to be using the HD bond for our bridge. We'll also need to slide in a 12 inch by 16 inch piece of foam board to build our model on, like that. We will also add the timber cutter to the Pittsco construction caddy. The timber cutter is what we'll use mainly to cut the pieces of balsa to length, and we can also cut them at specific angles, such as a 45-degree angle, which is indicated by this line, or a 75-degree angle indicated by this line. The timber cutter also has 30-degree and 60-degree markings on it for your convenience. You will need to be sure that you do not get your fingers underneath the guard because there's a sharp razor blade for cutting the balsa wood underneath. The most common cut for bridge building will be the 90-degree angle. To do this with the timber cutter, we'll simply put the wood at the back of the fence and depress the lever, cutting off the stick. We'll slide the timber cutter into place in the construction caddy and slide it up to the top where it will be easy to use. To begin the building process, we'll put our copy of the bridge side view and center it onto the foam board. We'll tape each corner to the foam board. Next, we'll cover our drawing with wax paper. We'll pull out enough length to cover the drawing, and we'll tape it over the drawing. We're ready to begin the construction process. I'm going to be standing on the opposite side of the construction caddy than you'll be working when you're working on your bridge. The first piece that we're going to cut out will be the main beam, which is at the level of the roadbed on the bridge. We'll place one of our balsa sticks at the very end of the bridge on one side and mark it at the other end with a slight pencil mark. Once it's marked, we'll insert it into the timber cutter and align it with the wood across the back fence of the timber cutter and align it with the mark just to one side of the razor blade. We'll depress the lever, cutting the stick at the mark. We'll place our stick in position. Then we'll use our pins to hold it in place. We want to be sure and pin on both sides of the wood in a place where we're not going to have other members coming down. We'll want to be sure and pin the main beam in 2 or 3 places just to be sure that it doesn't move as we add other members to the bridge. Kids, as we cut off pieces, we'll want to put the shorter pieces in our second tray to keep them separate from our long pieces. The next piece we'll put on the bridge will be the top piece. We'll put a piece of wood across the top, and we'll want to draw a 45-degree line on the end of this piece, and we'll want to cut it at that 45-degree mark. Again, we'll use the timber cutter. This time we'll use the timber cutter at a 45-degree angle, which is indicated by this line. We'll insert our piece of wood, being sure that we're parallel to the line and that we're at the mark that we marked on the stick. Then we'll depress the lever, cutting the piece of wood, and there we have a 45-degree angle. Sometimes it's easier to use the easy cutter to cut an angle like this, so let's do that this time. Let's place it against the fence back here, which is at a 45-degree angle, and we'll squeeze the handles and cut it at the mark. Kids, remember, when using the easy cutter, it has a very sharp blade right along here that will cut you if you get your fingers in it. So be very careful to keep your fingers away. We'll position this top piece where it needs to go, and then again we'll pin it in a couple different places. The next member that we'll put in will be this end piece. We'll want to cut this end of the stick at a 45-degree angle. Let's do that, and then we'll mark the other end of the stick. We'll place the stick in the timber cutter once again, aligning it with the 45-degree angle, pressing the lever, making our 45-degree angle. We'll position the stick back in place with the 45-degree angle that we just cut down here, and we'll mark the other end where it's supposed to go right there. Again, using the easy cutter, we'll place the stick on the 45-degree fence, and we're going to cut this slightly longer than what I marked it because we can always cut off a little bit more, and that will ensure us a good snug fit. Let's go ahead and put this piece in and see how our fit is. And you can see that the piece doesn't line up with the drawing. So that means that we need to take just a little bit more off. We cut it just a little bit long, but that's okay. We want a good tight fit, so we'll cut it again. Again, we'll place the stick on the 45-degree fence, and we'll cut just a hair off. And after a few times, you'll get the hang of doing this to where you'll get a good tight fit each time. Let's see how this stick fits now. And there it's in just the perfect position. So it's ready to be glued. We're going to use HD Bond glue, and we'll put a little bit of glue on each end of the stick for gluing. And with glue on both ends, now we'll put it into place, and we'll wipe off the excess glue. and make sure that everything is exactly where it's supposed to be before we pin this piece in place. We'll repeat the process for the other end of the bridge. We already have a stick with a 45-degree angle on it, so we'll just place it against the bottom piece, and we'll mark the other end of the piece where we need to cut it. Now we have a nice tight fit, so we'll glue both ends. Put it back in position. Wipe off the excess glue and pin it into position. Next, we'll go ahead and work on the substructure. We'll place a stick on the bottom piece in position. And again, at each end, we'll need to make a 45-degree angle. So I'll mark that. We'll cut the end of this piece at a 45-degree angle. We'll place the stick back in position with our 45-degree angle corresponding with this member coming down, and we'll mark the other end where it needs to be cut. And using the easy cutter, we'll place it against the 45-degree fence and cut it at the mark. We'll position the piece back, make sure that it fits correctly, and we'll pin it in position. Next, we're going to cut the 3 vertical members of the substructure. We'll position the stick and mark it. We'll use the timber cutter to cut our 90-degree angle, cutting it precisely on our mark. And we'll put it in to see how we did. That's pretty good. We'll mark our second one. And we're going to cut this with our timber cutter. Once again at a 90-degree angle on the mark. Check it for fit. And we'll repeat the process with the third vertical member, marking it and cutting it with the timber cutter. And we'll position this one. And it looks like all of these are fitting rather nicely, so they're ready to be glued. We'll take each one off one at a time. Add glue to both ends and place them back in position, being careful to align them with the drawing beneath. The next piece that we want to put in is this diagonal piece, and you'll notice that it needs to have a point on the end of it with a 45 angle on one side and a 45-degree angle on the other side. We'll cut that point first before we mark this point up here. To cut this particular piece, we're going to insert it at the 45-degree line, and we'll cut the end at the 45 degrees like that. Once we have our first 45-degree angle cut, we'll want to make another cut which will actually make a point on the end of this stick right in the center. To do that, we'll turn the piece over, reinsert it into the timber cutter at the 45-degree angle, and we'll cut it at the center point. As you can see, we have a nice 45-degree point right in the center of our stick now. This may take a few times for you to get the hang of, but I know that you can do it. Let's insert this piece and see how it fits. Notice that by cutting this point on this stick, we have these two members which this stick will bond to, providing us with a stronger joint. While it's in place, we'll go ahead and mark the length that we need to cut this stick at a 45-degree angle. Using the Easy Cutter, we'll cut this stick at a 45-degree angle at the mark. We'll put the piece back in and see if there's a final fit, and that looks real nice. At the pointed end of the stick, we'll want to be sure to apply glue to both sides of the point, and of course to the other end of the stick as well. We'll place it in position and we'll place a pin pushing against it to hold it in that clamped position. I've repeated the process for cutting the stick, and we have a nice fit here. So again, we'll glue both ends. And place it into position. And we'll place a straight pin into it to hold it in position while it dries. For some pieces, we're going to need to cut other than 45-degree angles. For instance, this piece will have to be at an angle other than 45. So we need to know what this angle is. To find that out, we'll use a protractor. We'll put the center of the protractor right at this point of this angle, which is called the vertex of the angle. We'll put the center point of the protractor there, align the 0 degrees mark with our horizontal line coming from that angle, and we'll read what the angle is out on the outer perimeter of the protractor. This looks like about 18 degrees. With our angle that we measured being 18 degrees, we're going to need to cut an 18 degrees off of 90, which will actually be 72-degree angle of cut. On the Pittsco timber cutter, we have a 75-degree line, so 72 degrees would be just a little bit off of the 75 degrees, and you'll just have to estimate where that's at. And we'll cut it at that angle and check and see how that works. We'll place the stick in position and see how we did. This looks like a real nice flush cut. So let's go ahead and mark the opposite end of the stick where we want to cut it at a 72-degree cut as well. To be able to make this cut on the Pittsco timber cutter, we're going to need to cut off the stick about 1/8 inch longer than our mark. We can just cut this off at a 90-degree angle. We can insert the stick into the timber cutter now, aligning it with our 72-degree mark, which is slightly off of the 75 degrees. And we'll align the blade with our mark on the stick, and we'll cut it at that point. We'll place the stick in position, and it looks like we have a real nice fit. We'll go ahead and put glue on the ends of the stick. And we'll put it into position. And remove the excess glue. And we'll let it dry there. I cut and fit the other side, and so we'll glue the ends of it. And put it into position. Like that. We'll cut the 3 vertical posts next, placing the stick in the position and marking it, and this will be a simple 90-degree cut. We'll go ahead and coat the ends of the stick with glue and place the stick in position. And wipe off the excess. We'll repeat the process for the other 2 posts. We're finished with the 3 main posts, and we're ready to insert the diagonal piece. So we're going to need to cut a point on the end of this piece, and then we'll measure back to find out our length. We'll place the pointed end of the stick into its position in the corner and mark on the other end of the stick where we'll cut it. We'll check the fit, make sure that it's good and snug, which it is, and then we'll glue it into position. We cut and fit the corresponding piece on the other side of the bridge, and we'll glue it now and place it in position like that. For the 2 remaining vertical posts, we'll make a point on each stick and then cut it to length and insert it and glue it. There we have it. Our next members will be the cross pieces, and we'll need to cut a piece that has a point on each end. So we'll go ahead and cut a point on one end and then measure for our other end. With our point in one end, we'll insert it into the corner, and in the opposite corner, we'll try and position the stick so that we have the point directly in the corner, and we'll mark that following the lines of the sticks in both directions. We'll first cut this stick about 1/8 of an inch beyond the mark, which will then allow us to cut the other end at a 45-degree angle at the X. We'll want to be very careful to align it with the 45-degree angle line on the timber cutter and exactly on the line that we marked for our position. We'll rotate the stick over, align it with the 45-degree angle, and cut it off so that we have the point directly in the center once again. We'll insert it into position and check the length, and we're just a little bit too long. This may take several times of trying to get this right. If we cut it too short, we'll have to work with a new stick. Notice that both ends of the stick are cut at points at 45-degree angles, and we now have it to where this fits snugly into our square, like that. We'll go ahead and take it out and add some glue and reposition it. just like that. We'll want this diagonal to go in the opposite direction of the other diagonal, and I cut a point on this end of the stick, so we'll put it into the corner and mark it on this corner as to where to cut. After getting a precise fit, we'll go ahead and glue both ends and slip this diagonal piece in position. For the remaining 4 pieces, we're going to notch one end, insert it into position, and mark the other end of the stick to be cut off at a 90-degree angle. We'll then glue those pieces into position to complete this side of the bridge. We've now completed one side of the bridge, and we're ready to set it off to one side to dry. And we'll work on the other side of the bridge using a new sheet of foam board and a copy of our bridge pattern. We've replaced the bridge side drawing with a drawing of the top view of the bridge, which shows us the location of several rectangles which will make up the roadbed. I've included a diagonal in each rectangle to increase the strength of the bridge and the roadbed. To build these rectangles, we'll want the long pieces to go the entire length of the width of the roadbed, so we'll mark it clear across and cut it at that point. We'll place this long side of the rectangle in position and then pin it to be sure it doesn't move. I've cut the second side of the rectangle to length, and we'll position it and pin it. For the ends of the rectangle, I'll position the stick at one side, hold it, and mark it on the other side. And we'll cut this small piece using the timber cutter right on the line. We'll glue the ends of this small piece and insert it into position. You can move the longer pieces back and forth to be sure that they're lined up once it's set. The other end of the rectangle we'll do the same way, positioning the stick, marking it, and cutting it off. After checking the fit, we'll glue the ends and place it in position. To cut the diagonal, we need to measure this angle to find out what angle to cut the stick at. We place the center of the protractor at the vertex of the angle, the 0 on the horizontal line, and we read the outside perimeter of the protractor at 11 degrees. This would mean that we would need a 79-degree angle. We'll insert the stick into the rectangle and mark it on the other end where we'll cut a 79-degree angle. You'll note that the drawing doesn't correspond exactly to our position of this diagonal, but that's okay. We'll place the stick in the timber cutter, and we'll place it at the 79-degree mark, which is slightly above the 75-degree line, and we'll cut it at our mark. After checking the length of the stick, we'll add glue to each end, and position the stick inside the rectangle like this. As you can see, I repeated the process for building each of these rectangles, and so now I have all 4 rectangles built. We've let the sides of the bridge and the roadbed pieces dry now, so we're ready for the final assembly of the bridge. To prepare for the final assembly of your bridge, we'll need to remove the pins that are holding the roadbed pieces and remove the roadbed pieces from the waxed paper. Another step in the process of the final assembly is to check and make sure that the 2 bridge halves are congruent. That is, they're the same size and shape, just like this. We'll construct the bridge on the top view of the drawing, using this as a guide for placement of the bridge sides along this side and this side, as well as where we'll place the roadbed pieces. We'll position one of the bridge sides onto the top view of the drawing, making sure that the center line of the bridge is in line with the center of the side. We'll pin this into place using several pins to ensure that it does not move. Likewise, we'll position the other side and pin it, being sure that it's on the center line as well. As we're working our way down the bridge, adding roadbed pieces, we want to also add pieces across the substructure to help hold it together. These would be cross members. We'll put in a stick and mark it and cut it to fit. Once we've cut the piece to length, we'll add glue to both ends and insert it into position. We'll repeat the process with the other 3 roadbed pieces, inserting them in position above their top drawing positions and gluing them in place. We'll also glue into place a couple more cross members at the bottom of the bridge between the substructures. As you can see, now we have the 4 roadbed pieces in, and we also have 4 pieces or cross members on the substructure glued into place. To finish up the assembly of the bridge, we're going to add some cross members to the top part of this bridge. We'll do this according to the drawing that we made, showing the position of these cross members. We'll first need to cut a cross member to fit right across here, But we're not going to measure it at this point because, as you can see, these bridge sides can move in and out. So we'll make our measurement from down on the drawing, going from the inside of one side to the inside of the other. We'll make a mark at that point and cut it. Before inserting the cross member into the bridge, we'll check its length against the drawing to be sure that it's correct length. We'll then glue both ends and position it like this. You'll need to hold both sides of the bridge together while you put a clamp on it to hold it in place. We're going to make another cross member piece this length, and again we'll measure on our drawing to be sure that it's the right length. We'll cut it and we'll check our length to be sure that we have it correct. Then we'll glue both ends and put it into position. We'll repeat the process for our last cross member right here. For the diagonal pieces of the top of the bridge, we'll notch one end of a stick like this. We'll insert the pointed end of the stick into the corner at the top of the bridge and carefully mark the other end of the stick where it will be cut off to fit into the corner. We'll use the easy cutter to precisely cut the point on this stick. Let's see how it fits. We'll insert the stick and we'll see that we have a nice snug fit. So now we can glue both ends and put it into position. We'll glue both ends and position it where it belongs on the top of the bridge. We'll repeat the process, having cut a point on the end of this stick, and we'll mark, cut, and glue this other diagonal into position. To finish the bridge, we're going to add 2 more cross members at the roadbed level at each end of the bridge. We'll place these on the roadbed, mark on the outside edge of each side, and cut it to length. We'll add a little bit of glue to the side of each end of this member because this will be setting on top of the roadbed. We'll position it like that. I've repeated the process for the other cross member at the other end of the bridge, and we'll glue it into position right there. We've completed the assembly of our bridge, and now we're going to let the glue dry. It's best to let the glue dry for about 24 hours to set up the maximum bond. We've completed the assembly of the bridge, and now we're ready to remove the bridge from the drawing board. We'll remove the clamps and we'll remove the pins which hold the bridge to the board. With the completion of our bridge, we're ready for the testing process. For testing, we're going to use the Pittsco DI 2000 structure tester. We have a bridge adapter which will hold the bridge. These two abutments will allow the bridge to set across the required span, and this rod will pull down on the bridge as if it were exerting force. As you can see, we've set the abutments so that we have a 10-inch span, which is what we started with for the bridge. We have chosen a test block that has a hole in it and is 8 inches long, 2 inches less than the span. We'll insert this test block into the bridge through the roadbed and over the bolt, then positioning the bridge evenly across the abutments. Once we have the test block in position, we'll use this C-washer and this nut to help apply force on the bolt. We'll lift the bridge up slightly and begin the nut threading onto the bolt. And we'll thread it down until it begins to get close to the test block. We'll insert the C-washer around the bolt and bring the nut on down so it's just in contact with the C-washer, like that. Once we have the nut and C-washer in position, we'll adjust the bridge so that we have equal amounts of overhang on each of the abutments. Once we have the bridge in position, we'll use this black handle to pump up pressure in the structure tester, which pulls down on this rod. This red button will release the pressure in the system, allowing the rod to come back up. The amount of pressure, or the amount of force that is, that's being exerted by the structure tester will be displayed on this readout. To zero this readout, we simply depress the black button. Before we begin applying pressure to the bridge, we'll want to be sure that everyone in close proximity has their safety glasses on. Now we're ready. Before we begin applying pressure, we'll hit the red button to make sure the cylinder is at the top and the black button to zero out our LED display. Now we can begin applying pressure. And as we apply pressure, we'll see that the bridge breaks at this joint right here. As it turns out, my bridge only held 48 pounds, but I'll bet you can build a bridge that'll do much better. Until then, we'll see you real soon.